Hey, it's Annette and Austin. We have another lab for you guys. This one's pretty easy to do. It's called Astronomy of Asteroids. And basically what we're going to do is we're going to be given pictures of the sky, and we're going to see stars, and we're going to see some moving objects, and you have to figure out which are asteroids. So in the olden days, before they had software, what they would actually do would they'd hold up a sheet of glass and trace the stars, and then maybe like 30 minutes later they'd trace the stars again, put the layers of glass on top of each other, and see if anything moved. So lucky for us, we have software, makes it a lot easier. Just like every lab, you're going to log in the same way by not logging in really. And here's our lab. So we'll file, load images, image 1, and go ahead and select. So these are the pictures of the sky that we're given. We're just going to use the first one, hit open, and Annette will take it from here.
Okay, so now gotta move our chairs a little. Okay, so now for the second part, you're gonna go File, Load Image Files, and then you're gonna load your image 2, and you're just gonna want to make sure that it's not the second one down, because you want a difference in times. You want a longer times, and that way you can really tell what the asteroid is. So we're just gonna say like this 10 one. Okay, so now you're gonna go Image. Oh no, you're going to go File, Image, View/Adjust, sorry. So Images, View/Adjust, then you're going to have both of them selected, press OK. Then you're going to go ahead and look at these. So this is the first one, and this is the second, Image 1 and Image 2. And you can see that we have basic stars that are there on both. So this one's there, this one's there, this one's there, and these are the same. And then we notice, well, what's in this picture that isn't in this picture? And you can see that this star has moved somewhere. So that's really not a star, it's an asteroid. So we're going to go ahead and exit out of these, and then you're going to go Image, Blink, and then it tells us select a star for field alignment. So this is our first image. So you're going to select the stars that didn't change in the picture. So we're going to hit this one, you're going to press Continue, and then we're going to hit this one, and then Continue. Okay, so this is the second image, and it's just telling you to click on the stars that were the same, just so it aligns it. So Continue, and that was the second one. I guessed it, and it's correct, so Continue. Okay, so now these stars are going to be the same, and it's just going to blink this picture. Oh, and then look, there you go. That's our asteroid. So you're going to press Stop, and then you're going to identify the target, and that's our asteroid. So there it is. Press Continue. There it is. Press Continue. And then there you go. So then what you're going to do is you're going to go Image, Measure, and we're just going to go ahead and measure Image 1. This is the universal time that the picture was taken, and this is the date. So everything's good here. You're going to rename this too, just so we know this is Image 1. So just go like 01 or something. You're going to press OK, and then we're going to make sure that field size is 8, just because sometimes it changes, and we have a right ascension and a declination. So you're going to press OK. So then we come up with this crazy screen, and you're going to select at least 3 more reference stars, if possible, on the left hand. So let's look. So this star, this star. So you're going to press OK, and then we're going to do this star, press OK, and then this star, OK. So then once we've done that, we're going to press OK. The accuracy of our solution, yes. Okay, so now we're going to press OK. Now we're going to locate star number 1 on image 1. So that's this star, OK, this star, OK, and then this star, OK, and then yes. So now this is our solution. We're going to go ahead and just accept it. OK, record the measurements on our report list, yes, and then OK. So now OK to close the windows. So now we're going to do the same for image 2. So you're going to go Image, Measure, Image 2. Okay, so universal time, date of observation, Oh, yep, and then we're going to rename it, just so we know, to O2 for our second image. You're going to press OK. So now select at least 3 stars on the left hand. So all of these are good. So now we're going to locate them on the right hand. Press OK, this one, OK, and this. OK, and you can tell the U is our target object. So everything's good. Press yes. We're going to accept this data. OK. Record measurements. Yes. OK. And then it's OK to close the window.
So once you actually record your data and save it, to open it back up, go to Report, View, Print, Save Text, Exercise Format. Okay. Oh, it should pop up. Ours was down here in the corner, but this bar will pop up. And now what you want to do is open up your spreadsheet that Burke has put into your student file, and it'll look just like this. Once again, with this lab, we're going to be using formulas to help us calculate, so we don't have to do all this math. So yeah, try to line that up so you can see both spreadsheet and your data, and start entering the numbers. So right here, this is going to be, think of it as image 1, even though it says the 92JB14. That's image 1. Think of this as image 2. So for the time of the images, you're going to go to Universal Time, the OBS UT, and go image 1. We have 04, 53, 15, 53, and 14. No, I'm sorry, 15. We'll get down to image, or the time of image 2. We have 6 hours, 49 minutes, and 15 seconds. So this is showing you the elapsed time between the two images. Basically, the computer calculated that through all the formulas. So you can click on a box and kind of see. You can see the big old formula that we have. So yeah. Now we're going to do the declination of the images. So for image 1, where'd that go? Okay. For image 1, we went away again. Okay. There we go. Okay, image 1, the declination. We have 11, 14, 24.9. 14, 24.9. And for image 2, the declination, we have 11, 17, and 2.7. Alright, now go down to right ascension of image 1. We have 15, 30, 33.34. And the same for image 2. 15, 30, 35.76.
Okay, so then the angular displacement, so basically in the difference between the two pictures, like if you were to actually look at these pictures in the sky, your head would have to tilt upward to see the second image because of like the difference in time. So basically that's just calculating the angle like in the sky that it changes, and then the angular speed is how fast the asteroid goes, like how fast the asteroid moves between the two pictures. Okay, so we're just going to exit out of all of this data. So now what we're going to have to do is on our spreadsheet, our next part is Never mind, we are going to look at it full screen. The next part is measuring the distance of the asteroid. And we have AST West and then AST East, standing for Asteroid West and Asteroid East. Basically, this is just saying it's going to help us measure the distance of this asteroid. So it's going to take one in the west, saying like just on the opposite sides of the world. Okay, so we're going to go ahead and start that now. So you're going to go file, load image 1, and we're going to replace the current image, and then we're going to take it with at east. Okay, and then we're going to go file, load image 2, and then we're going to replace it with an image, and then we're going to scroll down a little more, and then we have our asteroid west, and we're going to say image. Just kidding. We're going to say image u/dust, and then we get both of ours selected. Press OK, and then we can see we have, it's a little darker of an image over here. But we can see our images, and then we're just going to exit out of that because we don't need that. We're going to say image blink. Okay, so we're going to. Okay, Austin's going to help us with the next part.
Yeah. Alright. So we're going to do pretty much the same thing we did with the old image. I'm just going to start selecting the stars to base it off of. And now we'll go to image 2. And these are the same picture, but one's in the east, one's in the west. So we're going to find that distance. Okay, that's close enough. And image 2 is actually right there. Go continue. And now we can blink them. So you can see that blinking. And you can stop it. Now we're going to identify target. And this star looked like it was moving. And okay. Never mind. So it's up here. I don't know why that's so off, but hit continue.
Okay, so now what you're going to do is we're going to go ahead and look at our report. So we're going to go report use/print, exercise format. And our stuff isn't here, so we're going to measure. Oh yeah, we still have to measure the second image. Did we measure the first image yet?
I don't think we did.
Oh, never mind. So now we're going to measure the first image. We forgot about this step, so you have enough time. You're good.
That was all.
Oh, okay. So that's why our blink. Okay, should we just start over?
No, just keep going.
Okay.
Okay, so what we ended up doing, that was for the blinking. So
you can still use that. Usually on the last video, I think we did it reverse. Like we did this first, and then we blinked it. But it's the same thing.
So we're going to select the 3 stars. So you have 1, 2, 3. That one. Okay, so locate the first star. Hit OK. Second star, hit OK. And third star. Yes. Okay, that's our data. We want to record it. Cool. Now we can close out and do the same for the second star, or second image, I should say. So that's good. And we'll hit OK. So reference star 1, 2, 3. Oh, near the target star. Whoops.
So free of star. So you're just gonna. So it says locate an area near the target object that is free of stars on image 2. So we're just gonna say right here that's free of stars. So okay, we're gonna select our solution, accept it. Record it. Yes. Okay. We're gonna close our windows, and so now what we're gonna do is report use/print exercise format. So there we go. Now we have all of our stars, and we're going to take our Excel sheet right here, and then, let's see, can I get this without it closing out? Okay, so I'm just going to cover up this part, but this is, we didn't rename it, but these are at east and at west ones, so just don't get confused if you don't rename it. So, okay, now we lost. Good. So we're going to move this so we can see it. Sorry, it's hard to organize all this stuff. Okay, so we're going to write down our right ascension. So 15. Okay, so 15. Could you read that after me?
Yeah, so 15, 30, 39.97.
Okay, so then our at east, or asteroid of the east, so underneath the bottom one.
15, 30, 32.98. 32.98.
Okay, so then our asteroid west declination now is 11, 17, 21.7, and then our declination of the east asteroid. Okay, so then now once you have that, it's going to compute all of this other good stuff for us. The distance to the asteroid, so that's just showing like the distance across the sky, like we already said, and basically we're going to change it so it's like 1 in kilometers and okay.
And for the reason it gives us kilometers in astronomical units, because kilometers, that's a huge number. An astronomical unit is more, I mean, that's more kind of reasonable when you're talking about huge distances. So that's why it looks kind of small, but in reality it's pretty big.
And then just remember that the moon is roughly 400 times like closer, so that's why we use the moon.
Yeah, so that gives us, this gives us astronomical units, this gives us a reference, so okay, that's how many times the distance of the moon is.
Yeah, it's just easier for us to get the astronomical units because it's closer. So then there you go, you're finished with your lab. Congratulations!